Hello everyone. In this session we will try to learn about the inverse trigonometric functions. Firstly we will try to find the inverse of the trigonometric functions. So before going to the inverse, we will try to recall some of the features of sine x. So suppose f is from R to R by fx equal to sine x. If the function is sine x, we can see that the domain is R. Domain is R. And our codomain is also R. And what is my range? If I recall, the range is from -1 to 1. So how has this sine has evolved? Sine is a circular function, and it has came from this particular circle, unit circle. If I try to recall, and why the domain is R? Because if I, for a particular angle, say theta, then sine is defined. What is the definition of sine? Sine of theta is basically our perpendicular by hypotenuse. Okay, now what is my, if the circle is unit circle, this circle is unit circle, that means the radius is 1 unit. Then how can I find these coordinates, this particular coordinates? Okay, so now say this coordinate is x comma y. So that means what? This particular length in the x-axis is x, and this length is y. That is why this particular point is called x and y. Now what is sine theta? Sine theta is perpendicular by hypotenuse. So my perpendicular is y, my hypotenuse is 1. And what is cos theta? Cos theta is basically base by hypotenuse. So base is x, hypotenuse is 1. So my sine theta is y, cos theta is x. So that means our this coordinate can be rewritten as cos theta comma sine theta. In a similar fashion, if I just keep on doing this, completing the circle, this is for first quadrant. If I try to find, like, if I draw this particular line, then my new theta is this one. This is my new theta, and I will form this triangle. And again, if I do the same thing, I will suppose this theta is say 30 degree. Now this theta is suppose 120 degree. Now I will similarly get some different values depending upon my angle. And if I can see that this theta starting from 0 degree to a full rotation, I will get 360 degree. And obviously it can go beyond that, but nothing new. I'm not going to get anything extra, because 0 to 360, all the values I'm going to get, and after that the same repetition will going to come. So that is why we say that the period of sine theta is basically 360 degree or 2 pi in radians. Same for cos theta. Okay, now how my range is from -1 to +1. Now if I closely observe this particular phenomena, my second coordinate, that is my y, is basically sine theta, right? So that means what? If my point is over here, that means if my theta is like this, if this is my theta, this is my y. If this is my theta, this perpendicular length basically denotes my sine theta. So this line are basically sine theta. Okay. And now if I draw like this, now negative something, negative, like up to what? Up to -1. In this case, I will maximum, this is what? This is -1 and this is +1. So in the positive, if I draw these vertical lines in the upward, the maximum and the tallest line that I can draw is basically of one length 1. That means which one? This particular length, and this is basically sine 90. This is sine 90. So that is why our maximum possible outcome is 1. And similarly, if I see this one, that means sine of 270, like this one. This degree is sine of 270. At 270, I can see that a value going to exactly -1. So that means the maximum value is 1, maximum value is -1. Now you can also evaluate, like how to evaluate sine 270 equal to sine 90 into 3 plus 0. Then since this is odd, I will write it like this, cos 0. Okay, and there will be 1 minus, and I will write this as -1. So sine 270 is -1. Okay, so the range is clear. Now if I try to particularly plot this particular function, plot the graph of this function, how can I achieve that? Okay, so if I see in the first quadrant what is happening. In the first quadrant, at 0 I will get 0. After that the value has increased. Then again more increment. You can see that the lines are increasing as the theta is increasing. So up to maximum 1. So that means what? If I draw in the first quadrant from 0 to 90, the value has increased till 1. Then similar fashion happens, but this time in decreasing. The value decreases. So like this, decreases. Now the same thing is going to happen, but in the negative part. Okay, now increment, but in the negative side. So increment, but in the negative side. Sorry, the function has decreased, and now it will increase. Look, the values are increasing. In negative side, this is increasing. So now this will increasing. So this will be my function of sine, and my range is from -1 to +1. So this is how my graph has evolved. Now similar fashion you can get cos also from the same graph, but the cos is not vertical lines, it will be horizontal lines. So now this is my graph of fx equal to sine x. So my domain is clear, range is clear. Okay, now my next question, what should be my next obvious question? Is this function, because my objective is to find sine inverse x, so now this is my function. So is this function invertible? So what is my domain? Domain is -infinite to +infinite, and range is R, because this is not going to stop here. This is just keep on going like this. This will keep going in the negative part also. So naturally I can see that. Okay, now is this function 1 is this function 1 So what is the definition of 1 how to check whether a function is 1 or not? I will take 2 points and I will say fx equal to fy, and that should imply that x equal to y. So this is my definition of 1 So is this particular function 1 Is this particular function 1 Say what is sine 30? Okay, what is sine 30? So sine 30 will be somewhere here, and I know that at sine 30 I will get half. Okay, and what is sine 180 minus 30? Okay, sine 30 is half. And what is sine 180 minus 30, which is equal to sine 150? What is the value of sine 150? Okay, I will try to find the value of sine 150. our natural way is to 19 to 1 plus 60, which is equal to cos 60. And since this is in the second quadrant, there will be plus. So cos 60 is half. So I can see that at 30 degree, I will get half. At 150 degree, the image is also half. That means what? F of 30 degree is same as f of 150 degree. Is that going to imply that 30 degree is equal to 150 degree? Obviously not. Obviously not. So that means this function is not 1, 1. Okay, if this function is not 1, 1, then this function is not going to be invertible. But still, let us check onto also. So is this function onto function? So for a function to be onto, I will check whether the range is same as codomain or not. Okay, codomain is R and the range is minus 1 to 1. This is my range. My codomain is R. Are they same? No, they are also not same. So this function is also not onto. So neither the sine function is 1, 1 and neither it is onto. Then how can I say that inverse of sine exists? So now this is the problem. So this particular function, this exact sine function, is not invertible exactly as it is. So it is not invertible. So how can I achieve the inverse of sine? So that means I have to change something in this function. I have to give some extra restrictions so that this function becomes 1, 1 and onto. If I see clearly that if I'm just drawing this sine function again. Okay, I'm restricting the sine function in this portion only. I mean, I don't want this extra portion up to from 0 to 2 pi. Okay, if I see from 0 to 2 pi, this is one particular period. But is this particular period 1, 1? Okay. So is this particular function 1, 1? No. If I draw this line, this function is not 1, 1. Also, if I draw this line, there are 2 points I'm getting at which this function is not 1, 1. Because at 30 degree, the image, and at 150 degree, the image is same. So obviously, this function is not 1, 1. Okay, now then let us try. Okay, let us try this one. So where is the problem? If you can see the exact problem area, the problem, if I want to remove that problem, that what is happening, these points, like if I pick these two points, I can see that this point also the value is same, this point also the value is same. So at these two different points, like this point and this point, they are two different points but their images are same. Okay, if I try to visualize this is a particular point X, this is a particular point Y. Okay, now but their images are same, their images are exactly same. That means what? This is a point X and this is a different point Y, not same as X, but I can see that their images are same. So that is the main problem. So if I take this portion, I cannot take this right part, because that will not let me that will violate my 1, 1 condition. That will become many 1, right? That will become many 1 function. So I have to eliminate that particular part. And in a similar fashion, if I see this portion also, if I take this portion up to here, in the right part it's clear, and in the left part also a similar thing happens. In the left part, if I suppose this one is x and this one is y, if I see this x and this y both give me the same outcome. So that way also, if I take this portion, I have to eliminate this portion, because if I do not eliminate this portion, obviously our function will become many one, and that I definitely don't want that. I don't want that. So I have to eliminate this one and this one, and these portions obviously I have to eliminate for another reason. If I do not eliminate this portion, obviously if I do not eliminate these areas, then there will be, now check on 2. Okay, now for on 2 case, what is the range of sine? The range of sine is -1 to 1. And what was my codomain? My codomain is R. So naturally, to make this sine function a invertible function, I need this function to be onto. That means I somehow have to set my codomain as -1 to 1. I have to set it. So if I pick this portion, like up to this one, from this to this, I can see that my codomain is basically -1 to 1. Basically -1 to 1. And I'm avoiding this particular portion for one reason. Suppose if I pick this portion, then obviously this is not going to be 1 1. And if I pick this portion, then obviously the same problem will occur, because this one and this one, if I draw a particular horizontal line, I can easily see that again, like this portion and this portion, from suppose this one is a particular point, this one is a particular point, these 2 points have same image. Obviously this is again going to be many one function, so that this portion is also removed. Likewise, this portion is also removed. Okay, now what is the reason that I should also remove this portion? What is the reason of that? That if I take this portion, this from minus pi by 2 to pi by 2, if I take this portion, I also have to remove pi to 3 pi by 2. Why should I remove that? So I should remove this portion for the same reason. Like if I draw one horizontal line, I can see that this particular line is intersecting 2 points. That means these 2 points will give me this. Suppose this one is x and this is my y. This x and y will give me same image. So that is why all other portion will automatically be eliminated, just to make it a invertible function. So I am drawing it fresh. So in this whole sine function, if I just take this portion, I'm just taking out this little portion from the whole sine function. Okay, if I just pick this portion, now check whether this function is 1 1 or 1 2. This is the whole fx equal to sine function, and this is a little portion of that. Now okay, so how does it look like? So this is from minus pi by 2, that is minus 90 degree. This is minus 90 degree to plus 90 degree, and this is 1, this is minus 1. Okay, now check whether this function is okay, this function up to this much, only this much. So now this is a new function, but with restriction. Now what is my domain? My domain, you can see from the picture, is minus pi by 2 to pi by 2, including these particular points. So minus pi by 2 to pi by 2. And what is my codomain? What is my codomain? If the codomain is R, then it will be not same as the range. So I have to set the codomain as -1 to 1, which is defined by fx equal to sine x. Now check whether this function is 1, 1 or not. You draw any horizontal line. You will see that particular horizontal line will exactly intersect at one particular point. That means this function is 1, 1. Okay, now for onto, you can check the range. The range is -1 to 1, and which is same as the codomain. That means this function is also onto. So since this function is 1, 1 and onto, my new fx with restrictions is invertible. This restricted function is now invertible. Now if I know that this function is invertible, then how does the inverse look like? So I will denote this inverse function by like this, by this symbol. Is the inverse of sine. This is the notation. Okay, now what is the domain of sine inverse, and what is the range of sine inverse? Range or codomain are same. So for the sine function, the domain was minus pi by 2 to pi by 2, and range was -1 to 1, and that will be exchanged. Like the domain of sine inverse will now become -1 to 1, and the range will become minus pi by 2 to pi by 2. These two things will be exchanged. Okay, now what will be the graph of sine inverse x? How to draw it? So if I know that the inverse functions, how to get an inverse function? In an inverse function, the domain and codomain swaps, the x-axis, y-axis changes. So every input, suppose what is the inverse function? Suppose f of x equal to y. If this function is invertible, now I can write x equal to f inverse y. That means f inverse y is equal to x. So that means suppose f is suppose D is the domain and suppose C is the codomain, and my inverse function will look like this from C to D. Okay, inverse function will be from C to D. So the domain and codomain changes its place. And in this case, you can see that x is the input and y was the output. And in this particular case, you can see that y is the input and x is the output. So naturally, the x-axis and y-axis also change its position. So suppose now I know already that this is my fx equal to sine x, in which this particular function is, this is fx equal to sine x, in which this function is invertible. Now I want to know what is the graph of sine inverse x. So if the x-axis and y-axis changes, suppose this is x dash, y dash. So I can see that this function is increasing towards what? In the positive direction. So if the x-axis and y-axis swaps, then how this graph will look like? This is increasing towards positive direction. So now the inverse function will also increase towards the positive. Now look, in this case this is y, and after changing its position, this y-axis will become my x-axis. So this will look like this, right? Now again this was my sine x, sine inverse x. How to draw? This is decreasing negatively. This is decreasing negatively. So my y, this is my y dash. This is my y dash. After swapping, this will be my new y dash. This will be my new y dash. So this will go towards and decrease like this. Like this. Okay. So this is my f inverse x function, also denoted by sine inverse x. So this is my inverse function. This is my actual function. So after changing the x and y axis, I will get my inverse function. So this is my inverse function. Now if I discuss some of the things, like if sine of theta, if y equal to sine theta, then obviously sine inverse y equal to theta, because sine has inverse. Okay, now from this one, if I use y equal to sine theta, and again if I replace in this second equation, what I will get? Sine inverse y is again written as, from the first I will get y equal to sine theta. So I am writing sine. So this is one property that I have derived. Okay. Okay, now theta will be taken from minus pi by 2 to pi by 2, because theta is the angle. Okay, now what about sine of sine inverse x? Sine inverse x or sine inverse y, because y is used here. What is its value? Okay, what is its value? So in the similar fashion, this time this time again I will use 1 and 2, but this time I will use 2 put 2 in 1. That means take the value of theta is sine inverse y, and put in the first equation. So what you are going to get? So y equal to sine theta, and theta is same as sine inverse y. So sine of sine inverse y is y. So this is your second result that you are deriving from these two equations. Those will be very useful while solving some problems. So this is the end of our first part to getting the inverse of sine function. So we have understood that the domain codomain changes. To get the graph, I will just simply change the x-axis and y-axis. So I will restrict the sine function to make it invertible. Then I will swap the x and y-axis to get sine inverse function, and we have derived these little two results from these things. And now I will proceed towards the inverse. We will try to find the inverse of cos function, then tan, and so on. Thank you.